Let's go ahead and solve a couple more simple practice problems of an inclined plane. And so we'll start with some inclined plane, and it has some height. And let's say we don't know the height, and we don't know the length we will travel along the incline or this ramp here. And of course, we're using this ramp to push some box to the top. And let's say we do know the weight of this box. Let's say that it is 50 pounds. So the weight itself is 50 pounds, but the effort it would take to push up this ramp, which would be considerably less, let's say that effort is only 10 pounds. And we have someone pushing this box up this ramp. And so the question becomes, what is the mechanical advantage? Well, if we look at our example, we are only given forces. And so the question is which mechanical advantage equation should I use if we're only given forces? And I look at that F and I remember our AMA-free equation. Our AMA, our actual mechanical advantage, is equal to our FR, or our force resistance, divided by our effort force, or FE, or again, in short, AMA-free. And we know what our force resistance and our force effort is. We can easily plug in both of these numbers. The force resistance is just the weight we are trying to move using our machine. The weight is 50 pounds. And the effort force, the force we actually apply using our machine here, is clearly only 10 pounds. And so what do we get? Well, pounds divided by pounds cancels out, and 50 divided by 10 is just 5. And so our mechanical advantage is just 5 to 1, or just simply 5. And then let's try another example. Let's say we have another incline, and this time I'll draw it backwards, so all our inclines aren't pointing the same direction every time. And let's say this time we don't know the weight of the box. We just know that it's a box that I want to push up with some force. And so let's draw ourselves a person pushing it up this ramp. So we don't know the force, but let's say we know the distances this time. Let's say it's a tall ramp. Let's say this thing is taller than the person pushing it up, so he very much needs a ramp to get it up there. Let's say it's 8 feet tall. And let's say this ramp is 60 feet long. So this is the distance I would have to travel. I would have to push this box to get it up to the top of the ramp using this machine. And so the question is, what would be the mechanical advantage? And I encourage you to go ahead and pause this video and try and see if you can figure this out on your own from here. And so hopefully you paused the video and tried it on your own, and if not, you can just go ahead and follow along with me. In this example, we are not given forces, we are given distances. And I look at that D in distances, and I see the formula we are obviously going to have to use is our IMA-DER equation, because IMA deals with distances. IMA-DER, DE, distance effort, divided by distance resistance, DR. And we know what our distances are. The question is which one is our DE and which one is our DR? Well, our DE is the distance of our force effort using the machine. So it's the distance we travel to use our machine. And if we want to use this machine, we have to push it up this ramp, which is 60 feet long. So our distance effort is clearly 60 feet. Whereas what are we trying to do? Well, we're trying to get this box on top of this 8-foot platform up here. That is the distance resistance we are trying to overcome. So on bottom, we will just write 8 feet. And feet cancels out. 60 divided by 8. Well, 60 divided by 8, that's not quite as straightforward as 50 divided by 10. Maybe we can't do that in our head. We can always pull out our handy-dandy calculator. We can say, what is 60 divided by 8? And what do we get? We get 7.5. And so we say our mechanical advantage is 7.5 to 1, or just 7.5. And so hopefully that wasn't too painful, and you're beginning to see which equation we should use when solving for the mechanical advantage of a machine in a simple example like this. And hopefully you are ready for maybe less simple applications of these formulas when solving for the mechanical advantage of a machine.